The new section is Basics of Hypothesis Testing. The first thing we'll talk about is the null hypothesis. Different books have different symbols to represent the null hypothesis. I'm going to use HO. The null hypothesis is a statement that the value of the population parameter is equal to some claim value. It's a statement about the standard deviation, the mean, proportion, or proportion. It's a statement about some parameter. Actually, I could say about the value of these parameters. The value is some definite number. Definite number. That is, the null hypothesis might be that mu is equal to 7.2. Or it might be that the standard deviation sigma is 3.81. It always has equality. It always has equality. Once you write HO, you better have equal. You may say that the proportion is 3.04, but it must say equal. Some definite value. HO is this. Some older textbooks may not say that. The alternative hypothesis, denoted by H1 or HA. The alternative hypothesis is something other than, well, it's a statement about sigma or mu or p, but it isn't the same as the null hypothesis. Okay, the alternative hypothesis is the statement that the parameter mu sigma p, that the parameter has a value that differs from HO. Okay, it's something other than HO. Okay, so now let's decide what what H1, I'm going to use H1 for alternative, what H1 can be given some information. Now, here's some examples. HA, the alternative could be that mu is greater than 0.6. It could have been that mu is less than 0.6. Or it could be that mu is not equal to 0.6. Okay, not equals to would mean both of those. If mu is not 0.6, well then it's either smaller than 0.6 or it's bigger than 0.6. It could be that the alternate is that the standard deviation is bigger than 7, or the standard deviation is less than 7, or the standard deviation is not 7. That means bigger than or less than 7. So now, what if I give you some situations? In this little exercise, we want to decide what HA and HO should be. Okay. So, suppose that you are told the following. The mean height of a basketball player is at least, I don't know, 6 feet 5 inches. So, first thing is, the null hypothesis is as follows. It's going to be that the mean height is 6 feet 5 inches. Now, you know that at least 6 feet 5 inches, the mean is at least 6 feet 9 inches. This means that the mean is bigger than or equal to 6 feet 5 inches. Okay, now when it comes to finding H sub A, and here's the ticket right here. When it comes to finding HA, you cannot use the statement that has equality. This statement has equality. The other one would be that mu is less than 6 feet 5 inches, and that's HA. If it didn't say at least, if it said the mean was more than, well, that'll be the next problem. So here it is. The HO is the easy one. It has equality. Now they're telling you that the mean is greater than or equal to, that means at least, 6 feet 5 inches. The other one is if you're not greater than or equal, you must be less than. There are three. Either you're greater than, you're equal, or you're less than. Well, if you're not this one, if you're not greater than, and you're not equal, then you're less than. And when you go to pick the alternative, you pick the one that does not have the equal line. This says equal, so and this one does not. So I'm going to pick that one for the alternative. It's the one that doesn't say equal. It's the one that fails to have the equal sign. Suppose you come to know the following. The standard deviation for the length of time you wait on a bank line. You wait on a bank line is 2.5 minutes. actually is no more than 2.5 minutes. Excuse me. Is no more than 2.5 minutes. Well, 2.5 minutes, that's their null hypothesis. The standard deviation. I want to see something a moment, please. Okay. Thought I used the wrong symbol. The standard deviation is 2.5. Now, let's look at this line. They say the time you wait on a bank line is, actually these two, is no more than 2.5 minutes. It's no more than 2.5. Well, what that means is, so the standard deviation is no more than. It's not more than. Is not more than. Let me use that word. Is not more than. Well, you have greater than, less than, and you have equal. Well, it's not the more than. Excuse me, but that's the less than symbol. Excuse me. It's not the more than. It's not that one. So it's these two. So sigma is greater than or equal to 2.5. But since that has the equality, since greater than, less than, well, you don't want to be greater than or less than. Greater than or equal to. You don't want to be greater than or equal to. That is, you can have the equal sign. So you put less than. Do not just say, oh, you don't want to have equal, so I'll remove equal. No, 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 no. You can't use the greater than equal. You can't even use the greater than. If it has the equal sign, you can't use that symbol. You can't use the greater than symbol. So you have to use less than. And that's your HA. That's your alternative. That's the alternative. Let's look at another one. You can't use either of the two symbols if it says greater than or equal. Likewise, less than equal. If it says the mean waiting time at the post office is less than 11 minutes. Well, the null hypothesis, that's the easy one. Mean is 11 minutes. But now it says that the mean is less than 11. Since that does not have the equal symbol, I will call that my null hypothesis. If by chance it said the mean waiting time is less than or equal to 11 minutes, if it said that, well, I can't use either of those two symbols. I can't use the less than, I can't use the equal. Well, there's only one left, and that's the greater than. And then I would have said mu is bigger than 11. That would have been my alternative. But that was not what we were told. We were not told that the wait time is less than or equal to 11 minutes. That would be no more than 11 minutes. You don't have to wait more than 11 minutes. That means 11 minutes or less. But it didn't say that. Okay. To save a little time, let's use this problem with a couple of words taken out. Suppose the mean waiting time at the post office is 11 minutes. That means that you are told that the mean waiting time is 11 minutes. Is means equal. Is less than means less than. The mean waiting time is 11. Since that's equality, I jump on it. That's the null hypothesis. The alternative hypothesis, well, it can say equal, and it does. Well, there are 3 symbols, and you can't be that one. So then you can be these 2. Or better yet, you can't be, well, if you're less than or greater than, that means you're not equal to. If you're not equal to 11, that means you're bigger than 11 or less than 11. You're just not 11. Okay, and that's how you can say it. I mean, if you wanted to, I know I wouldn't mark it wrong. Instead of writing mu is not equal to 11, you can say mu is greater than 11 or mu is less than 11. But that's the same as saying it's just not 11. If it can be more than 11 and it can be less than 11, well, then you just can be 11. Now, the next and last thing we'll talk about before we start doing some real problems is the test statistics for this section. Their test for the proportion is Z is equal to P hat minus P divided by the square root of PQ over N. PQ over N. The test statistic for the mean, that Z is equal to X bar minus mu over sigma, and we multiply the top by the square root of N. That's if N is greater than 30. If N is less than 30, you use their t-score. Excuse me. You use one of those 2. When we get into that section, we'll talk about N being bigger than 30 or not being bigger than 30. Excuse me. The test statistic for the standard deviation. It's a new one. It's chi-squared, which is n minus 1 times the standard deviation of the sample divided by the standard deviation of the population. Excuse me. But both of these get squared. Okay, and that finishes up this section, basics of hypothesis testing.